Today, we are going to present an experiment that allows us to analyze the milk. First, we analyze the lipid content of milk using thin layer chromatography method. We place a clean silica plate in the steam room to remove any moisture before use. And after, we prepared the indicators. For olive oil, we put a small volume that we mixed up with chloroform and covered with aluminum foil to prevent evaporation. For butter, we make it melted and mixed with chloroform, and the cholesterol indicators was pre-prepared. We are now going to extract the lipids of the milk. We measure a specific volume of milk and pour it into a centrifuge tube. Chloroform, methanol, and a few drops of acetic acid are added to aid in lipid extraction. To balance the centrifuge, we prepare a second tube filled up with water of the same weight. The tubes are centrifuged for 10 minutes to separate the components, glycides, proteins, and lipids.
After centrifugation, the glucid layer is discarded. The lipid layer is extracted using a pipette man and transferred into a round-bottom flask. The flask is placed on a rotary evaporator to quickly remove solvents under reduced pressure. Finished, the flask is degazed to collect the extracted lipid residue. Now we are going to do a thin layer chromatography. We retrieve the dried silica plate and mark it with the names of our samples. A small drop of each sample is applied to the plate. The spots are dried using a hair dryer. Each sample is applied twice for consistency. The plate is then placed in a solvent mixture of ether, hexane, and acetic acid, allowing the solvent to rise by capillary action. After development, the plate is sprayed with sulfuric acid and returned to the steam room to reveal the results. We saw on the result that different spots appear to the silica plate, each corresponding to a different compound in the lipid mixture. These compounds migrate differently depending on their polarity and interaction with the solvent. By comparing the migration patterns, we observed that the lipid composition of butter is most similar to that of milk.
We start with making a standard range in which we put Bradford solution in each cube with a different volume of beta in each cube and top up with water. We run the solution in the spectrophotometer. Rich after, we prepared 20 cubes, and since we need to put the same volume in each cube, we put 2.5 milliliters of water in each cube and draw a line. Secondly, we need to calibrate the column. We make a mixture of blue being vitamin B12 and tartrazine. The mix is added to the gel in the column. Once this has penetrated the gel, more water is added to prevent the gel from drying out. We can immediately see that the dyes divide and that the blue descends faster down the column because it's heavier than the tartrazine descent, and finally the vitamin B12. Then we collect the dye fragment in different cubes. On the 20 cubes have been filling, we run the cube through a spectrophotometer to study the absorbance of the blue, the vitamin B12 and for the tartrazine.
In order to measure the proteins present in milk, it's necessary to extract them. We place phosphate buffer, milk, distilled water and TDA in a centrifuge tube and we centrifuge the mix. Once this has been done, the sample can be collected. It got a solid phase called the pellet and a liquid phase called the supernatant, which is the one phase we need as it contains our proteins. We make 2 cubes with supernatant and Bradford solution. We measure the absorbance, we make a plot of the absorbance as a function of the mass of BSA and take the equation of the line. We redo the column with the supernatant where we recover the 20 cubes, but we keep only the one where the volume is equivalent to the volume 0. We realize two new measures with the spectrophotometer, with Bradford solution and some of this cube. We do the same things with proteins and we obtain the protein concentration of milk. Finally, to calculate the concentration of proteids, we average two absorbents, which we enter into the equation to obtain the mass of proteids. Divide by the volume of supernatant used, and you get the proteids concentrations in the milk.